Hey everybody, here we are with the molality problem set. We're going to go through a few problems, just kind of examples. Before we even get started, I am going to put the formula for molality at the top of the screen. We will write it a few times, but remember that molality is going to equal moles of solute over the kilograms of the solvent is the formula for molalities. That being said, this problem that we are given gives us the mass of sucrose, so table sugar C12H22O11, and the mass of water in grams. Remember that molality is given in these lowercase m. So when we do write our molal concentration, we'll write it with a lowercase m at the end. All right, let's move on and let's get this problem started. So we are given some information. We're given the solute mass, we're given the solvent mass, and we're asked to find the molal concentration. So the first thing we're going to do is convert the grams of solute that were given to moles and the grams of the solvent to kilograms. So this one we want in moles, and this one we want in kilograms. So in order to do that, again, I'm going to put molality equals moles of solute over kilograms of solvent. The units we need are going to mean that in order to go from grams to moles in this first one, I'm going to need a molar mass. For this one, I'm going to need to know that 1 kilogram is 1,000 grams. Because in converting grams to kilograms, you know what we're going to do. All right, so molar mass first of C12H22O11. We're going to calculate that using our periodic tables as we've done in our previous times, many times over. Starting with carbon, 12 times its mass, which is 12.011. You have your calculator, you can be doing this on your own. You don't need me to show you how. For hydrogen, we're going to take 22 times the mass on the periodic table. My periodic table had rounded it to 1.008, so I'm going to get 1.76 grams of hydrogen, and then my oxygen is going to be 11 times 15.99. I'm going to get 175.989. I'm going to add those up. I'm going to get a total mass of 342.297. Remember, yours can be close. If it's not exactly the same, your numbers will be slightly different. That's okay. All right, so the first thing we're going to do is convert the grams of solute to moles. So this one, we're going to go 17.1 grams of C12H22O11. We know that 1 mole of this is going to weigh 342.297 grams. when I do that math, I get a very small number of moles. I'm going to do the same, or I'm going to convert, next I'm going to convert the grams of the solvent to kilograms. So I'm going to start with my number of grams of H2O. I'm going to go to 1 kilogram, knowing there are 1,000 grams of H2O in 1 kilogram of H2O. And I'm going to know that I'm left with 0.125 kilograms of H2O. All right, so there we've done our first step. Our next step is going to be to actually calculate the molality using those different pieces of information. So I'm going to move on to a clear slide to calculate the molality. Okay. So we calculated from step 1, we got the molar amount was 0.04996 moles. And I'm not rounding it yet because I'm going to do that at the end. And this is of the C12H22O11. The second calculation I did gave us 0.125 kilograms of H2O. All right, so our molality then is going to be our moles of our solute over our kilograms of our solvent, which for us is going to be that those two numbers divided by each other. That's going to give us a value of 0.3996, which I'm going to round up to 0.400. We could write out the word molal, but really what we should be writing is the shorthand unit of a lowercase m. And that's our first problem. Moving on. Oops. All right, our next problem has iodine in carbon tetrachloride, is used when we need it for certain chemical tests. How much iodine do we need to add to prepare a 0.48 molar solution of iodine in CCl4 if 100 grams of CCl4 is used? So again, we're going to write out the molality formula. What we're going to do is we're going to identify which one is the solute and which one is the solvent. So in our case, I'm going to say that the solute is going to be the iodine, and the solvent then is going to have to be the CCl4. Okay, so that being said, now we have some other pieces of information. So let's summarize what we have. We're given the molarity of the solution altogether. We're given the solvent's mass, and we're asked to find the mass of the solute. Our first step is going to be to convert the grams of solvent to kilograms. So again, I'm just going to remind you of the formula. I'm going to do a shorthand. All right, so I know I've got to get this into kilograms. That's the first thing. And in order to do that, start with our mass of the solvent. Doesn't matter what the identity of the solvent is. We're not using a molar mass at all. It does matter that there are 100 grams though, and that there are 1,000 grams in 1 kilogram. So dividing that, I'm going to get 0.100 kilograms of the solvent. Next step is going to be to use the equation for molality to solve for the moles. So our formula is this. I know the molality of the solution from a previous slide is 0.480. And I know the kilograms. Because I just calculated that. So I'm going to plug in and I'm going to solve for this guy. Remembering that x in this problem is solving for the moles of the solute gives me this number. Now, in the original problem, it did ask me for the mass of the solute. So the last thing we are going to do is convert that value to grams. And in order to go from moles to grams, what do we use? Hopefully you said it out loud, because I'm not there to encourage you to say it out loud, but we're going to use the molar mass of the solute itself, which in this case was I2. So we're going to calculate that. $126.904 times 2. Gets you 253.808 grams per mole. All right, so our very last calculation is to take our 0.048 moles of I2 to grams. By multiplying across. Which comes out to be a mass of 12.183 grams of I2. All right. That's it for our molality video. If you have any questions, please feel free to reach out. Otherwise, enjoy.